Well, this is a test. All right. Good morning, everyone. Thank you so much for coming to my presentation. I am Rajesh Vijay Raghavan. I am a doctoral student from Harvard Business School. I'm going to present to you a question from a topic that's been close to my heart in the area of banking. The exact question that I'm studying is recognizing loan losses in banks and examination of alternative approaches. The motivation for my question goes back to the mortgage crisis, which stirred an ongoing debate on the role of transparency and financial system stability. A key part of this debate is the importance of having a robust set of accounting rules. This, in turn, revived a long-standing debate among accounting scholars and policymakers on as to how should bank account for their held for investment loans. Current GAAP uses what is called the incurred loss model, where banks recognize loan losses only if there is an objective evidence that a probable loss event has occurred and the loss is reasonably estimable. This rule prevents banks from recording losses that are expected but that do not yet reach the probable threshold. And implicitly, it allows managers to use only a subset of available information unless default is probable. In June 2016, the FASB issued a new rule for accounting for loan losses, which the key features of the new rule itself are that it eliminates the probable threshold for loan loss recognition and it broadens the information set that managers can consider when measuring the credit losses. This rule is called the Current Expected Credit Loss Methodology, or the CECL, and will be effective in December 2019. With that setting in mind, typically when you look into prior accounting research, we study after a rule change happens in place. However, I have identified a setting where you can say something reasonable even before the rule change actually happens in place. Specifically, the research question that I'm interested in is, I empirically examine if it is possible to construct a predictor of future loan losses that performs better than the incurred loss model without having to expand the information set that is already permitted under the incurred loss model. The second question I ask is, what is the impact of expanding the information set to this model to include forward-looking information such as the one proposed in CECL? So, in these two questions, I exploit the difference in the information set allowed under current GAAP and what is proposed under the new GAAP. And I study the trade-offs between allowing for efficient use of available information and the use of broader information in place itself. Now, why is this question important? The CECL rule is widely believed to be the biggest change ever to bank accounting by the bank regulators. And there is this notion that banks are typically considered opaque, and it's important to understand their accounting rules, which largely determines how opaque or transparent they are. The catalyst for the CECL proposal was the criticism that the incurred loss model delayed recognition of loan losses during the mortgage crisis. In the pre-crisis period, banks had unusually low levels of reserves against eventual loan losses. So, it remains an open question if the reason for this untimeliness is because of the aspects in the incurred loss model itself. Now, how do you make this question researchable? Ideally, an evaluation would compare the allowance under the incurred loss model and the CECL model to identify which is a better predictor of future loan losses. While bank financial statements currently report the losses under the incurred loss model, I do not have data on the allowances under the CECL model because the CECL model comes only in effective in December 2019, as I had earlier discussed. This paper uses a prediction model of future net charge-offs to obtain counterfactual estimates of allowances, and I use historical data to evaluate how the rules perform itself. For my first research question, in terms of is it possible to construct a predictor of future loan losses that performs better than the incurred loss model without having to expand the information set beyond already permitted, I use the same information set that managers consider under the ILM itself, the incurred loss model itself. Then I construct a prediction model by removing any constraints on how managers use this information and apply judgment. And I call this the limited information model. The key idea behind the limited information model is that it uses the same information as allowed under the incurred loss model, but it estimates allowances without any management judgment. However, it's not clear if the limited information model would perform better or worse than the incurred loss model for at least two reasons. Banks possess private information which is not accessible to me as a researcher. Second, banks could in turn have their own allowance model, and when I model an allowance limited information model, might not capture the exact model that each of the banks themselves have. However, if the limited information model outperforms the incurred loss model, it would then serve as a good benchmark for my further analysis. To my empirical strategy for my research question 1 uses quarterly bank level data in the periods between 1996 to 2012. I use only historical data from the bank balance sheets, such as loans that are past due, loans that are non-accrual, and loan portfolio composition that managers typically use under the incurred loss model. I use these information and a prediction model from the machine learning literature, Lasso, to predict future loan losses. Using machine learning methods is one of the novel aspects of my paper, where I treat estimating allowances as a prediction problem. And the idea behind this choice is that when banks set aside allowances, in essence they are trying to predict future loan losses, which will help them fine-tune their estimates. And considering that is fundamentally a prediction problem, I borrow research from the recent economic research from Professor Senthil Mullainathan and Susan Athey, who suggest for bringing in machine learning methods for more broadly into social science research. The advantage that the Lasso brings for my question is that it improves prediction accuracy as well as reduces overfitting, two key attributes in my model performance itself. Moreover, the Lasso offers a feasible and an objective approach for estimating loan loss allowances. To actually implement the Lasso, I use a rolling window out of sample technique where I estimate Lasso in a particular window and then make predictions of my allowances in out of sample. And then to actually evaluate how well my model performs relative to the incurred loss model, I use a common measure used in forecasting and more broadly in machine learning literature in terms of root mean square. The idea behind the root mean square is that I take the predicted allowance from my model and I see what's the difference between the predicted allowance and the actual loan losses that the banks recognized. Then I take the actual allowance that the banks recognized in their financial statements and I find the difference between that and the actual losses that the banks recognized. So the idea is that the model that has a lower root mean square is relatively a better model. To document the findings from my first research question, I find that the limited information model in fact outperforms the incurred loss model. This bar graph summarizes the results from my analysis of my prediction problem for using historical data in the periods 1996 to 2012. I run quarterly estimates, but I summarize these in terms of the cumulative root mean square. And as you see, the performance of the limited information model is significantly better than the incurred loss model in itself. So what this graph tells is that if you use the same information set as allowed under the incurred loss model, but once you use the Lasso model for prediction, it significantly performs better. Now, for my research question 2, I build on the limited information model, but extend the information set that managers can use in estimating allowances. I call this the full information model. If there are gains in using broader information in my setting, I should find significant differences between the performance of the full information model and the limited information model. However, estimating allowances under the full information model hinges on the ability for me to proxy for the manager's information set. To encounter this challenge, I use data set focused on US banks that operate in one US county alone. The advantage that this brings me is that then I could look into county level economic information such as home prices, income, unemployment, bankruptcies that I anticipate banks that operate in these counties would use when the CCL goes into place. To actually estimate the allowances in the full information model, I build on the limited information model, but expand the information set that the model takes to include county level microdata. I use the rollings out of sample technique to estimate allowances, But now when I compare the accuracy, I compare the accuracy of the full information model and the limited information model. And the idea behind that is the model with the lower root mean square performs relatively better. Again, I summarize the results in this graph. The two bars on the rightmost were similar from the graph that I already showed you, but the addition is on the leftmost bar, which is the performance of the full information model itself. What I find is the full information model does not bring in much benefits compared to the limited information model, as we had already discussed. Now, the analysis thus far documents findings that limited information model indeed outperforms the incurred loss model, and there's no difference between the limited information model and the full information model. Now, the natural question to ask is, how would our banks recognize allowances under the limited information model? This involves actually taking the allowances that the banks had recognized under the ILM and then finding the difference between what the banks would have recognized and the limited information model. The idea is that if the banks had used the limited information model, this difference would give an indication of how much more or less the banks would have had in allowances in the period of my study. To do this, I use the measure as a percentage of loans and again summarize the result in this graph. On the x-axis, you see the difference between on an average of the difference for across all banks from each year. On the y-axis, I document the percentage in terms of the percentage of the difference as the percentage of loans. As you see, there have been periods where the limited information model would have suggested that banks would have lower allowances. There are periods, especially after the financial crisis, that the limited information model would have suggested that banks would have had more allowances. And interesting aspect of this graph is that it says that starting in 2006, banks would have started, my limited information model would have said that the banks would have started to increase their allowances compared to what they already had in the incurred loss model. On an average, the magnitude difference between the allowances for banks under the limited information model and the allowance in the incurred loss model is about 22%, which is economically meaningful. Now, what are the implications from my research question? My analysis suggests that incorporating broader information in allowances is beneficial, but is primarily driven by how this information is used rather than the way the use of information itself. Considering that I use machine learning to mimic managerial decision making, a model with the same information as the incurred loss model but using a lasso performs significantly better than the incurred loss model itself. And the main contributions of the paper are that there is a large academic literature that have studied factors that influence bank loan loss estimates. A key part that I emphasize is that a big part in the estimating allowances is the role of the accounting rules itself. My findings also question whether discretion enhances the quality of the accounting in my setting. I also propose a way to implement the CECL rule by using objective and verifiable information. I have been working further on progressing this research further. Noticeably, I have been speaking with regulators from the SEC and the Federal Reserve, and I look forward to hearing your comments as I progress this paper along. Thank you.